In our last video, we introduced the concept of clean data. Clean data is the utopian state for all data analysis work, as it requires no transformation prior to commencing analysis and commencing work. We also introduced the tidy data principles. These provide us with a framework for what this clean data should look like. In this video, we'll start to explore how to go about cleaning data in Excel. There are many tools available to us for this task, and the supporting article for this video explores the pros and cons of a number of these. However, it is our recommendation that you use Python to clean data in Excel. Not only does this provide you with all the capabilities and all the tools of the other methods, it future-proofs your skill set and provides a launchpad for careers in other areas such as data science and machine learning. In this video, we will demonstrate how to work with Excel and Python together. We will introduce the best practice for doing so, and we will walk through an example of a simple find and replace task. All code and data used on screen in this video will be available to you in the lesson resources panel. Let's get started. How do you work with Excel and Python together? Well, the process for working with Excel and Python is actually very, very simple. It's, in fact, so simple it's often overlooked. But it's worth exploring because there's a few things in there that if we don't get right, we leave ourselves open to a world of pain and problems that can come back to haunt us. So the process is quite simply a three-step process. The first step is to import the data from Excel into Python. The second step is to carry out the cleaning activities we need to do in Python. Now, these will be implemented with codes and scripts that we write and can reuse in Python. And then finally, the third step is to export the data back to Excel. So this is a very simple three-step process, but there are a few things in here that we need to be aware of as best practice. First of all, always take a copy of your data when you are importing it from Excel into Python. Now, the good news is the way we will show you how to carry out this task will naturally do this for you. But if you do work directly on your original data and you make a mistake, you have no way of going back to the start and actually rectifying that issue because you've overwritten your original data. And similarly, in the third step, always export your data back to Excel with a new file name. And this is for the same reason. If we overwrite the original data and we find out we need to go back and correct something, we've overwritten it, we can't start again. So two simple best practice steps to include in the very simple process for working with Excel and Python. Let's look at an example of how we can get Excel and Python to work together. And we're going to do this with a simple find and replace example. A hypothetical scenario is considered. Let's say we work for a company that sells kitchen units. And as the data analyst in that team, we're interested, or we have been asked to provide analysis on the volume and total sales value of units by customer. Now, it's a common task. We'll have systems that collect this data for us. So we go off to our systems and we extract the data, but there's a problem. And let's just have a quick look at how this data then comes out of the system. You can see here that the data on first inspection looks clean and it looks tidy-ish. We've got observations as rows, so our orders are rows. We've got variables as columns, so units ordered and price per unit as columns. However, when we look at the cell values, so specifically the price per unit value, we see a problem. Now, it looks like a number, but Excel will actually treat this as a text value because there's a few things in here that just force it to be text and not a number, the dashes, the pound sign, the comma. So for us to actually use this data and carry out the analysis, we're going to have to do some cleaning tasks. We're going to approach this cleaning by exporting this data to Python, finding and replacing all the little bits of text in that value that make it non-numeric, replacing them with nothing, and then pushing the data back to Excel. So let's have a look at how we do that using Python. What you can see on my screen here is a VS Code implementation of a Jupyter Notebook. Now, I'm going to assume you are familiar with VS Code. I'm going to assume you have a basic familiarity with Python, and I'm going to assume you have a basic familiarity with Jupyter Notebooks as well. The supporting article for this video covers other sources and other tutorials where you can learn about Python if you aren't familiar with some of these concepts. And it also covers off the basic knowledge that you will need in things such as pandas and Python operations to be able to get through this cleaning exercise. So I won't be covering those in detail here, and I will be assuming you are okay with these for the rest of the video. The notebook you can see on the screen is the notebook that's available to you in the lesson resources, and we're going to walk through it line by line and look at what the code is doing. So the first thing to do is actually set ourselves up for cleaning this data. So the first thing to note is that I've got a folder on my desktop with the Jupyter Notebook in, the .ipynb file. And I've also got a copy of the messy order data, the Excel file that we've extracted from our system, in the same folder. Now it's important it's in the same folder for reasons I'll explain later as well. So first of all, we're going to import pandas as PD. Pandas is a very useful package for manipulating data, and it's one that we will repeatedly come back to. The first task we need to carry out is import our data into Python. Now, if you remember, this automatically takes a copy of the data, so we're ticking off one of the best practice boxes already just by importing the data into Python. Unfortunately for us, Pandas has a very handy read Excel function built into it, and we can call that by doing PD. Remember, we imported Pandas as PD, .read Excel. And we only have to pass one mandatory variable to this function, which is the name of the file, so messy order data XLSX. Because that file is in the same folder as the notebook, we don't need to put the rest of the file path in there. It will automatically look within the same folder, and if it finds it, it will import it. But we can also put a file path in there as well if the file is located elsewhere. Like a lot of Pandas functions and a lot of Python functions, there are optional variables that we can pass into this function as well. And sheet_name is one such variable. Now, I'm going to pass sheet 1 in because that's the name of the sheet that has the data in Excel. It's generally a good idea and best practice to name the sheet you want to get the data from in Excel, because if there's more than one sheet in Excel, which is quite a common occurrence, it won't know where to get the data. So make sure that you name the sheet you're looking for or you want to extract the data from, because it will avoid any issues in importing the data. So let's just run this cell, and then let's run the following line, which will run and return the head of the data it's imported. Now, by default, a head returns the first 5 items in the data frame. So 1, 2, 3, 4, 5. Python indexes from 0, so 0 is effectively the first row of our spreadsheet. That's a little bit counterintuitive because Excel indexes from 1. But this is the head of the data is brought in, and we can see here we've got the same problem that we identified in Excel. So step 2 is to identify the tasks and carry out the cleaning activities that we need to. So let's just have a quick look at the data. Now, we want this data to be a numeric value, and it isn't because we've got things like pound, dash, 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 and comma in there as well. Now, the decimal point will get picked up as part of a number, but the other things will prevent it from being a number. So the first thing we want to do here is remove the comma. And we can do that very simply by implementing find and replace. So find the comma and replace it with nothing. Replace it with a null string. We can also do something very similar with pound, dash, 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 dash. we can find all instances of that and we can replace them with a null string. So those are the first two cleaning steps we need to implement. The third step we need to implement won't be too obvious at this stage why we need to implement it. But we actually need to ensure that the values are treated as numbers or numerical variables within Python. And I'll show you how to check this and how to change a variable type or coerce a variable type later in the code. But it's something we do need to check, because if Python thinks it's text and we export it back to Excel as text, Excel will treat, although it will look like a number in the Excel will treat it as text. So we still haven't got the data in a format we can analyze in Excel. So the first thing we need to do is replace the comma with a null string. Now, fortunately, Pandas has a very simple function that will allow us to do this to string values in the data series. So the messy data is a data frame. Within the data frame, our price per unit pounds variable is stored within a data series, and we can apply a function to that data series with the .str replace call, which means replace the string values of that data series, or go through all of the string values in that data series and replace a comma with a null string. Now, we actually then need to overwrite this back onto the original column. So we've got this assignation at the start that the column in the data frame we're interested in, the variable in the data frame we're interested in, is then a function of the old instance of that variable with the commas replaced as null strings. So let's just run this function and have a look at what this does by calling the head function again. So you can see here very quickly that the comma in that number has been removed. So if you look back here, we've got a comma, and if you look here, it's been removed. So that's been successful. We can do exactly the same with the pound dash 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 string here as well. We can find all instances of this and replace it in the pounds in the price per unit variable. So if we run that cell, run the code, and again look at the head of the data, we can see that that's been successful. It's removed the data. It's removed the text value, sorry, that was preventing it from being a number. The final step we need to implement is to look at the data type of the variable and check it's a number. And again, Pandas has a very handy call, which is .dtype, which will tell us the data type of a data series. So if we call dtype on the price per unit data series in the messy data frame, we can print the data type to the screen. Now, I'm going to wait to do that for a second, because the next element I've got here overwrites that data type to coerce it to be a float number or a floating point numeric number, which is what we've got here. We've got a decimal point, so that is what we want to coerce this value to export it correctly back to Excel. And then we've got an exact copy of the first line of code, which will look at the data type after we've coerced the value to be a float. So if we run this cell, and you can see here that it is outputted the data type, and the way this is outputted on the screen is as a result of the rest of the print function there. So I've asked Python to put in the additional text here to help us understand it a bit better. But we can see the data type initially is an object, which is a very generic data type in Python, and it's effectively treated as text when it's exported back to Excel. And we can then see here that the data has been coerced to be a float. So the data is now a floating point numeric value as we need to carry out the analysis. So that completes step 2. And if you recall, the final step is to export the data back to Excel. So we've got our messy data frame, which we've carried out the cleaning activities on that we need to. And the toExcel function is a Pandas function that will export to the file name we give the function. So if you recall, the best practice advice here was to export the data back to a new file so we don't overwrite the old data. And that's what we're doing here. So we're going to call it clean order data.xls. And again, this is an optional value for this function, but I'm going to set index to be false. Otherwise, when we export the data, we will get the indices that Pandas uses exported to Excel as well. So we don't actually want those in the Excel file. So I'm going to set it to false here. It defaults to true in the call. If you don't put a value in, it defaults to true. I'd encourage you to play around with the file, drop that value in and out, and see what happens to the export as a result. Now I'm just going to expand the Explorer here on the left hand side so you can actually see this in anger, because what happens at this point when we run this is you'll see that a clean order data XLS file has been generated in the same folder. Now if we just open up this data file as well, you can see here that all the issues we had preventing this column from being a numerical value have been solved. You can see down here on the right hand side that it's starting to do all the operations that you'd expect from a numerical value down here, which it doesn't do if you do something with text. So if we just plot text down here, it only counts them. And it also means that we can put in formulas to calculate the overall sales price as well. We can put in formulas to calculate the overall value of the sales, and we can then use this data in the analysis that has been requested of us. That wraps up this tutorial. We've looked at how to get Python and Excel to work together with the intention of cleaning data. We've looked at a very high level process for getting the two programs to work together. We've explored some of the best practice recommendations we have in doing so. And we've also walked through the code to carry out a very simple find and replace activity. In future tutorials, we'll go on to demonstrate how many of Excel's built-in functions can be replicated simply in Python. But we'll also go on to demonstrate how there's much more manipulation and much more capability within Python. And by learning how to use Python in conjunction with Excel, how it opens up a world of opportunity to us that wasn't previously available. It's also quite a personal journey for me, because this is where my journey into data actually began as well. I started working with data in Excel and ultimately hit the limitations of the program. Python enabled me to go past those limitations and do a lot more with data. A little bit of bonus material now that this video actually gives us an opportunity to investigate. And that's coercion errors. We saw when we were cleaning the data that we needed to coerce the text, or coerce a text value to be a numeric float value for the analysis to be completed in Excel. When you coerce values in Python, it isn't always successful. And Python has a really good go at trying to find and trying to identify things that look like numeric values when you pass it text to coerce, but it doesn't always succeed. And if it doesn't succeed, it returns a coercion error. And this is something we can actually observe in the example we've been looking at. So on the screen, I've got the code that we've previously run. And you can see here I've imported the data and I've run it up to the point where we inspect the head of the data. So you can see here we've got the messy values that we need to clean. Now I've added a line of code now that coerces the value before we attempt to do the cleaning. And if we run this, you see it returns a value error. It returns a lot of information here, but the last line here in the notebook is what we're interested in. Could not convert a string to a float. So while as humans we can read that text string and identify a number in there, all Python can see is a text string. It can't differentiate any numerical values in there, and things such as pound dash 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 prevent Python from interpreting this as a number. And as a result of that, it returns a coercion error. Now, if we very quickly run the rest of the code as we did before, and then get to the part where we coerce the values after the cleaning activities, and this is exactly the same code we ran a second ago, you can see quite clearly now it was an object before, and we can now coerce it to a float value because we have removed all non-numeric values from that string, and Python now can coerce it to be a numeric value.